Hello students, welcome to Educate. In the last class, we have discussed about this question. About these questions we have discussed. Now let's see about question number 1.5. What is here? This question is actually based on to calculate the average atomic weight. Average means what you know already. That means how to calculate average. That means what's the data, add all of them and divide by the number of data. So here is natural abundance, percentage of natural abundance of chlorine 35 is 75.77. That means if there will be 100 atoms of chlorine, then there will be 75.77 atoms whose atomic weight will be 35. In the same way, percentage abundance of chlorine 37 is 24.33, means if there will be 100 atoms of chlorine, then there will be 24.23 atoms whose atomic weight will be 37. That means molar mass will be 36 point this one and here this one. That has been written 35. That means there will be, if there will be total 100 atoms of chlorine, then their atomic weight will be 35.9689. And there will be 24.23 atoms whose molar mass will be 96.9659. This one is, that means 34.9689 is the relative atomic weight. 34.9689 is the relative atomic weight of chlorine 35. It is in the same way 36.9659 will be the relative atomic weight of chlorine 37. It is relative atomic weight of chlorine 37. Okay guys, how to calculate, how to find out average? So same here. So there is 75.77 atoms whose atomic weight is 34.9689. So the atoms whose total number of total weight will be this one into this one plus this one into this one divided by 100. So very simple it is. So that can be written as, here, or in other word, how to find out average? That means this one will be added 75.77 times. So better you multiply this value by this value. That will be the total weight of all the chlorine atoms whose atomic weight is 34.9689 or whose relative atomic weight will be 36.9689. In the same way, this value will be added 24.23 times. So better you multiply this value by this value. So that will be average atomic weight will be average atomic weight, that will be equal to that whole upon 100. So very simple here. Then also here only calculation left. So you will have to only calculate what will be 75.77. Do that. 75.77 multiply by 34.9689. That will be how much? 2649.6. 2649.6. Then after multiply 24.23 by 36.9659. That will be 897.9. 897.9. 897.9. That will be multiplication. That upon 100. That is u here. So now add this one. 897.9 by 2449. 8. That came 35.47. So average atomic weight of, by this data, the average atomic weight of chlorine will be 35.47, and you already know the average atomic weight of chlorine is 35.5. That is. Now let's see next question. In 3 moles of ethane, calculate the following number of moles of carbon atoms. So let's see here. In one molecule of ethane, the number of carbon atom is 2, and so in 3 moles will be how much? So 3 moles means with 3 moles will be how much? Firstly, let's see. 3 moles will be 3 into 6.022 into 10 by 23. That much. That will be the number of molecules of ethane. That will be, so here how much? 3 to the 6, 3 to the 6, 0, 6 3 is 18 into 10 by 23. That means 1.806 into 10 by 24. That much the number of molecules of ethane. Okay, so one molecule of ethane contain how much? 2 atoms of carbon. We have C2H6 here. So one molecule of ethane contain 2 atoms of carbon. So there is how much? This much. So 1.806 into 10 power 24 molecules of ethane will contain how much? 2 into 1.806, 2 into 1.806 into 10 power 24. So calculate here. So 3.612 into the 10 power 24. That is here. Number of moles of hydrogen, that into here 6. That will be number of moles of ethane. So number of moles of ethane will be that much only. Sorry, number of molecules of ethane will be that much only. So that is okay. Very easy question it was. Next, watch out this question carefully. Listen here. Enough water means how much water will require. That will be the enough. Enough water means not, that means if 1 spoon sugar and 1 bucket water. That's not mean. Enough water means how much water required, that is. So here what is that? In these questions, 20 gram of sugar are dissolved in water to form the final volume as 2 liter. So 20 gram sugar here. So what is, you have to find out concentration in mole per liter. Mole per liter means you will have to find out molarity of the solution. So molarity of the solution, let's see here. There is 20 gram of sugar. So molarity, that will is equal to, you know already, molarity is equal to number of moles of solute, number of moles of, here sugar will be there, solute is sugar, and that upon volume of solution is. Molarity you have to find out. So number of moles of sugar will be how much? How to find out? Sugar is molecular formula C12H22O11. That will be, there is 12 carbon into atomic weight of carbon 12 plus 22 hydrogen plus there is 11 oxygen and atomic weight of oxygen is 16. That is how much? 12 12 is 144 plus 22 plus 11 is 66. Carry 6. 11 was 11 and 6. 11 and 6 17. Add this one. 342. So number of moles of sugar, that will equal to 20 gram upon 342 gram per mole. So that will be equal to 20 divided by 342. That's calculate. Zero 0.059, 0.058, so 0.058, that much mole. So molarity, that will equal to 0.058, that much mole, that upon volume of solution is 2 liter here. So that will equal to how much? That much mole per liter. That means 0.029 mole per liter. That is the concept. That is molarity of the solution will be that much. Okay, clear guys? Now there is given density of methanol is given. What is the volume of needed for making 2.5 liter of its this much molar solution? This question firstly you try by yourself. If any problem there will be, I shall discuss. Okay, 1.12 this question try by yourself firstly. Okay. Next question, this is of related to the physics. You can solve there very easily, I think, but I shall hint you. There is given pressure, you will have to find out. Force per unit area you already know. So SI unit is Pascal, that's also you know. If mass of air at sea level is this much, mass of air is given here. If mass of air at sea level is, that means that much gram per centimeter square. Okay, so that's firstly you will have to convert into gram per centimeter square. So that's one you have to firstly convert it to kg per meter square. That you will have to find out in the mass. That is that much gram is presented, that much centimeter square. So in 1 centimeter square, how much in kg will be there, and in 1 meter square, the how much will be there. That you have to find out. Then after, pressure will be here. So force will be here, mg. What mass you will calculate, that one into acceleration due to gravity. That one, that upon area. So area is already given here. So area will be remain same here. Mass per unit area it is given. Mass per unit area is given in gram per centimeter square. You have to calculate mass per area in terms of kg per meter square. That, so that will be there and there. So force per unit area will be mg, and that will be the pressure. Clear? Clear guys? This is related to the physics, but even though that's the method, try to do this one in this way. If you feel difficultly, then already the team Educate is always ready to help who would like to take help. Now, then after is here. May the following prefix with their multiples. Okay, micro and this one. Micro is what? 10 power 6, 10 power minus 6. Multiples is 10 power minus 6. Deca 10 power minus 6. Okay. So like that one here. So in the prefix with here, this one. Prefixes and multiples. So that's you will have to match micro. So 10 power minus 6 here. Okay. This one I'm going to use. I think you already know. But even though micro, you know, 1 micrometer means 10 power minus 6 meter. This one. Deca means 10 power minus 10. Mega means giga, femto. This one. You are already aware in the physics. What do you mean by significant figures? This is the questions of physics here actually. In physics, you will have to study in detail. So that's you should there. I can do, but that will be the time taking. In physics also you will do, and in chemistry also. So let's finish. I have here left this one. Now let's this question. A simple, watch out this question. This one is chemistry. Let's see question here. In this question, it is given this biggest sample chloroform is carcinogenic. Carcinogenic means it causes cancer. Carcinogenic means on the prolonged consumption of chloroform, it will cause cancer. So we would like to take calculate this one which is carcinogenic, even though if that is in less amount. So there is, it is written 15 ppm. Concentration of chloroform is 15 ppm. Means 15 particles of chloroform is present in 10 raised power 6 particles of all of them. 15 particles of chloroform is present in total how much? When the total number of particles is 10 power 6, 10 power 6. So when total number of particles is 10 power 6, number of particles of chloroform is how much? That is how much? That is 15. 10 power, that means in percent term, when you have percent term, you will have to find out. So when the total number of particles will be 10 power 2, 100 means 10 power 2. So number of particle will be how much? 15 upon 10 power 6 into 100 means 10 power 2. So that will be equal to 15 into 10 power minus 4. That means 0.0015. That will be. Oh, 10 power minus 4 means just 0.0015. Okay. Or you may write 15 into 10 power minus 4 or 1.5, whatever you would like, 1.5 into 10 power minus 3. That is molarity how much? So molarity means when total volume will be 100. When total volume will be, their volume you find out, and then after in molarity in terms of, here it is ppm by mass given here, not by number. Okay. So that means here in 1 kg, if the total weight of the solvent will be how much, from there we have to do this like that. So this one questions you do by yourself. Okay. How to do this question? There is total mass of chloroform will be how much? Total mass of chloroform will be 15 gram. Molality means if total mass of this one, another one will be 1 kg. So mass of solvent, that will you have to take 1 kg. Okay, in that one you can find out. Try that. If will not able to do, because question is easy, and you should hear, if you you will think over this question, then you could solve the questions in your examination by yourself, because when you will solve the questions by yourself, that will sharpen your brain. But even though if you will not able to do that question, so I shall tell. Now let's see about this question. Scientific notation, how to express in the scientific notation. So there will be only one digit left to the decimal, and there must be one digit left to the decimal. So two questions I am solving, and remaining you have to do. So that means will be 4.8 into 10 power how much? 1, 2, 3. So 10 power minus 3. In this case, you will have to express in 2.34 into 10 power how much? 1, 2, 3, 4, 5. So 10 power 5. Remaining you do by yourself. How many significant figures are present in the following? So here, 0 is left to the decimal. 0 is left to the decimal here, this one. Here, so the significant figure is only 25. Because this 20 represent the position of this one and not the significant figures. Actually, the significant figures is based on the calculation values. That means the reported value in which the last digit will have the inaccuracy of plus minus 1. So significant figure is the number of digits in the reported value in which the last digit will represent the uncertainty by plus minus 1. So that is here. In the same way here, calculate. Do by yourself, this one you can do by yourself. Rounding off, have I to tell? From your childhood, you are studying about how to round off. So after here, this one is less than 2, less than 5. So that means that will be 34.2 only. Here less than 4, so like that. So you divide this one. Here how to round off? This one will be same. Now, the following are obtained to form different compounds. Okay, which of the chemicals over by the above. Okay, watch out here. In this question, which law is this question is good, and that is conceptual base. So I am discussing here. What is here? Mass of nitrogen, mass of dioxygen has been given. So in this case, and this case, what is here? Same number of dinitrogen. So that means here 14 gram nitrogen combines with 16 gram oxygen. So 1 gram will combine with how much? 16 upon 14. And in this case, second one, 16 gram. Okay, in second experiment. In second experiment, same 14 gram nitrogen combines with 32 gram oxygen. So 1 gram combined with how much? 32 upon 14. So this upon this is a simple whole number or not, that you have to find out. So 16 upon 14 is to 14 upon 32. This will get cancelled out. 16 to 32, that is means 1 is to 2. So 1 is to 2, that combines law of multiple proportion. So guys, in the examination, you will not get so much time. So what to do? If the two elements combine to form 2 or more than 2 compounds, then that law will be followed by law of multiple proportion. If two elements combine to form 2 or more than 2 compounds, or their ratio here, it is here 14 gram and here also 14 gram, same number of dinitrogen, but oxygen is different. Same here different, here same, but oxygen is different. So it will follow law of multiple proportion. Now what is here? 1 kilometer, how much millimeter, how much picometer? That's you know already. So have I to tell? 1 milligram, how much? So that's a very simple units. So you do by yourself. So in 2 nanosecond, how much? 10 power 1 nanosecond is 10 power minus 1 nanosecond is 10 power minus 9 second. So in 1 second, that will cover this one. So in 10 power minus 9 second, how much convert? That into 10 power minus 9 will be here. So you can find out. Okay, and the problem here, in 1 second it covered this one. So in 10 minus 9 second, how much? So that means 0.3 meter it will cover. Okay, this question here, this is the reaction here. This question, watch out carefully. 1.23, this question, watch out carefully. A and B react to form AB2. Identify limiting agent if you do this one. 300 atoms of A plus 200 molecules of B. So let's see here, one atom of A react with how much? One molecule of B. Here 300 atoms of A will react with 300 molecules of B. So that means 300 atoms of A will combine with 300 molecules of B, but 300 molecules of B is not available. So that's why B is the limiting reagent, because what's here is here 1 atoms of A so here is 300 atoms. So 300 atoms of A will combine with how much? 300 molecules of B, but 300 molecules of B is not available. Okay guys, this one. Now let's see about another one. 2 mole of A combined with 3 mole B. Guys, here 3 mole B only given here, not B2. Keep in the here, be careful. It is not B2, it is only B. So what here? 1 mole of A will react with 2 mole of B, because that is number of atoms. Here it is where in one molecule of B contain 2 atoms of A. So here that's why it will be for this one. Why? Because here 1 mole of B2 that will equal to 2 mole of B, because 1 molecule of B contain 2 atoms of A. 1 molecule of B contain 2 atoms of B. So that's why 1 mole B2 that equal to 2 mole B. So here how much? 1 atoms of A react with 1 molecule of B, means 1 atom of A combines with 2 atoms of B. So that's why 1 mole of A combines with 2 mole of B. Is there 2 mole B available? Yes, that is, oh no, sorry. So 2 mole of A will combine with how much? So 2 to the 4 mole B. So 2 mole of A will combine with 4 moles of A. Is there 4 mole B available? Not available. So that's why 4 mole of B not available. There is only 3 mole of B is. So that's why B will be the limiting reagent. Okay, guys. Now, 100 atoms of A combined with 100 molecules of B. So that is here. There will be no limiting reagent. In this one, 100 atoms of A will completely react with 100 molecules of B, because one atoms of A react with one molecules of B. That's why 100 atoms of A will react with 100 molecules of B. Now 5 mole A reacts with 2.5 mole B. So here also it seems that, so B also the limiting reagent. How's? Let's discuss. Read the question here. It is 5 mole of atom C, 2.5 mole of B. So 1 mole of A, 1 mole of A combines with, so 1 moles of A combines with 1 mole of B2 here, or 2 mole of B2B combines with 2 mole of B. So that is how much? 5 mole. So 5 mole will combine with how much? 10 mole of B. But 10 mole is not available. So B is the limiting reagent. Okay. Here 2.5 mole of A reacts with 5 moles. Here also not limiting reagent. Here anyone is limiting reagent. Both will react together. Because 1 mole reacts with 2 mole with this one. So 2.5 mole will react with 5 mole. And 5 mole available here already. So that is this one here, no limiting reagent. Now let's see question number 1.24. There nitrogen reacts with hydrogen and form ammonia. Here it is, question is calculate the mass of ammonia produced if 2 into 10 power 3 gram of, that means 2 kg, that much gram of dinitrogen reacts with 1 kg of dihydrogen. Okay, so let's see here. Firstly read the question, then after I solve. Okay, read the question. Read. Now let's see. Reaction is nitrogen reacts with hydrogen, gives ammonia. Balance the question. Here mass of nitrogen given how much? 2 kg. 2 into 10 power 3. That much gram. Hydrogen here given how much? 1 gram. 1 kg. Now, so number of moles of nitrogen calculate. So number of moles of nitrogen, that will equal to 14. Oh, sorry, not 14. 14 into 2. This one, number of moles of hydrogen, that will be This one number of moles of nitrogen is 71.42 and number of moles of hydrogen is 500. Now watch out the reactions. 1 mole of nitrogen reacts with 3 moles of hydrogen. So that much moles of nitrogen will react with how much hydrogen? That firstly you will have to calculate. So what that is? That is 71.42 into 3. Calculate. $214.26. So that much is the number of moles of hydrogen available there? Yes. The number of moles of hydrogen required is more than the number of moles of hydrogen required for the reaction. Okay, the number of moles of hydrogen available here. Oh, number of moles of hydrogen 71.42. Oh no, yes. So number of moles of hydrogen available is more than number of moles of hydrogen required to react with nitrogen completely. So that will be here. So here hydrogen will be not the limiting reagent because hydrogen is here available. The amount of hydrogen available is more than the amount of hydrogen required for the reaction. That's why hydrogen will be not the limiting reagent. In this case, hydrogen here nitrogen will be the limiting reagent. So here nitrogen will be the limiting reagent. So how much question is asking? What is how much ammonia will produce? That is mass of ammonia produced. So now let's see here. 1 mole nitrogen produces how much? Here 2 into 17 gram ammonia. Here how? Its number of moles I have calculated. So I shall take its number of moles and its mass directly. Or you may also take its number of moles and its number of moles. 1 mole of nitrogen gives 2 moles of ammonia. So 71.42 nitrogen moles of nitrogen will give 71.42 into 2. That much was ammonia, and that will be the number of moles of ammonia, and mass will be their number of moles into their molecular weight. Either you do like that or directly establish a relationship between here number of moles and mass. So 1 mole of nitrogen gives here 34 gram of ammonia. So that much nitrogen will give how much? Okay. So anyway you may do that. So 1 mole 142.84 moles in terms of moles, that much mole. So its mass will be how much? 142.84 into 17, that much gram. Either you do this one or directly you do that. 1 mole of nitrogen produces 34 gram of ammonia. By that also you can do, or by taking firstly by calculating the number of moles of ammonia produced and then after multiply by their molecular mass. Which would you like? By that much you can do. (2.428 gram). So convert it to kg, then you write 2.42 kg. So 2.428 kg or 2 kg 428 gram. That much ammonia will produce during this reaction. So yes, any of the reactants remain unreacted? Yes, here. Which one unreacted? Hydrogen. And what will be its mass? Third question, watch out carefully. Okay. Now, number of moles of nitrogen here, how much? 70. Firstly, watch out these questions. Take 1 minute time I am giving you. Then after I shall proceed on the third portion. And guys, for the IIT main examination, here these two type of questions not asked so much frequently as that of the questions of the third portions. That's asked. So third portions, how to solve the third portion of this one is too much important. So watch out this one carefully. First of all, watch how I did. Now let's see here. First is I am rubbing this one. How much are nitrogen? 71.42. Now let's see. 1 mole nitrogen react with 3 mole hydrogen. Oh, guys, I have rubbed that one. So you will have to watch out your notebook also. So what here? 1 mole nitrogen here. So that means number of moles of hydrogen required for the reaction will be how much? 71.42 into here 3. Why? Because 1 mole nitrogen, as you did, 1 mole nitrogen react with 3 mole hydrogen. So 71.42 moles of nitrogen will react with how much? So 71.42 mole of nitrogen will react with so that is calculate here 3 into 72. 3 into 71.42. 214.26. That much mole hydrogen required. Okay. Any problem here? Then after how much hydrogen is there? This much, 1000. So, and number of moles of hydrogen will be how much? 500. So, 500 moles of hydrogen there is, out of which 214.26 mole of hydrogen will react. So, how much number of moles of hydrogen reacted? 500 minus 214.26. So, that will be, because In this reaction, 214.26 moles of hydrogen has been reacted, and total number of moles of hydrogen available for the reaction is 500 moles. So what will happen here? Number of moles of hydrogen unreacted will be 500 minus 214.26. This is number of moles. So its weight will be how much? That's also you can find out when you multiply by 2 by their molecular weight. You will get weight of hydrogen unreacted. Okay, mass will be, so mass of hydrogen that will be 571.48. Okay, so till 1.24 we have discussed. From here onward we will discuss in the next class. It's all for this class. Thank you, Team Educate.